Good afternoon, everybody. I'm Paul Dawes, and Mode focuses on the enterprise wide area networking market. So it's a very specific vertical application. We leverage the Ericsson platform and the Equinix infrastructure to do that. And the way we do that is Mode is not an SD Wan provider, if you're familiar with SD Wan. Instead, Mode is providing a complementary solution to any SD Wan deployment. It's something we call a software-defined core, which gives us the ability to deliver the same kind of control, visibility, and flexibility to the core of the network that SD Wan does for the edge of the network. If you look at the deployment of a wide area network today, and I don't know how many of you are looking at that, but we look at it a lot, and SD Wan has solved some key problems. It provides an ability to easily connect, manage, and orchestrate enterprise business policy across a global network, across a global enterprise. And it does that with reliability, and it does that with security, right? But the control stops at the edge of the network. There's no control once you get into an access network from a service provider, particularly as you get into the internet, where you're running the internet core across the network. And that's the opportunity that we focused on with Mode. When you look at what happens in the core of the network, with the internet, BGP and routing and bouncing around and variability in that internet, it doesn't give the same kind of reliability that an enterprise has with traditional private networking like MPLS. And so what we do with Mode Core is we deliver a global backbone, purely software-defined, using some proprietary technology I'll talk about, to give enterprises the same kind of quality of service they got with MPLS, but to do it in a flexible, cost-effective way, a fraction of the cost, but with full visibility and flexibility in terms of how they deploy that network. And it marries to any SD-WAN deployment. So as we work with service providers and enterprises who pick Viptela or Versa or Silver Peak, that's their choice. Mode Core works with all of those and provides a better backbone infrastructure. And so when you look at the way Mode Core is developed, we run as an overlay network on top of really any underlay, but we've picked as our partner Ericsson, and with Ericsson the Equinix platform. And so we run that overlay network. We run nodes in the network. Obviously, as was being mentioned, there's 22 POPs around the world, all connected by private fiber. That gives us a great underlay to deliver services to our customers. At each of those nodes in the network, we measure, monitor, and control in real time. So the difference in our algorithm, which was developed at Cornell University, is that we're running a fully distributed real-time control system that actually guarantees optimal performance on any packet switch network. Now, we do that today on Edge Gravity, but as we work with Ericsson service provider partners, we mentioned there's almost 100 service provider partners. The whole idea of the Mode network is that the more nodes we have, the more routes we have to choose from, the more performant the network becomes. And so we're working with service providers to deploy those nodes deeper into the access networks. And when we talk about an edge capability, as I'm sure you're all aware, if you're an enterprise, I'm on an access network and maybe it's 10 milliseconds to get out to the edge of that network. If I can push deeper into that network and cut that down to 5 milliseconds or 3 milliseconds, there can be huge value in things like real-time communications, IoT applications, et cetera. And I haven't yet met an enterprise who wants more latency in their network, so we feel that it's a pretty good value proposition. Quick background on the technology. So I mentioned the two founders, PhDs out of Cornell, mathematicians, computer scientists who looked at the OSI stack, looked at the way we do networking today, and focused not on the higher level, TCP optimization, WAN optimization, but instead focused on the layer 2, layer 3 network, the routing layer. Protocols like BGP and OSPF evolved because there was no deeper understanding of how the underlying dynamics worked in a packet switch network. It was actually an open problem in networking for almost 40 years. The founders solved that problem. They solved the mathematics, derived the differential equations, which describe how any packet switch networks work. And then they applied control systems theory to that to design the first fully distributed optimal control system to use on a packet switch network. That, in conjunction with SD Wan, which is this edge control we talked about, gives us an end-to-end controlled solution where we can guarantee optimal control of packets throughout the network. So when enterprises look at running real-time traffic, running latency-sensitive traffic to their data center, wanting to get the same performance as they go to the cloud that they had when they were running their on-premise equipment, these are the kind of applications where Mode Core becomes critical for them. And by coupling it to SD Wan, it makes it easy for them to manage and orchestrate that across their entire enterprise. So to give you a quick background on the math, and I won't go into the formulas, I'm happy. There's an IEEE paper from 2014 which goes into exhaustive detail. But the National Science Foundation funded the research. And when the paper came out, they ran a test and tested this mode, what was called Halo algorithm, against Google's B4 system. Google has a great software-defined network called B4. They ran it on a national network with varying traffic loads. The Google engineers and the NSF engineers were able to show that Mode could push 3 times the amount of traffic through the same network topology. And as Google started hitting the limits on performance, it was doing it at 10% of the latency. The second test that happened was a variety of carriers were working with Mode. One of them, AT&T, did a software-defined network challenge. Took their national network, thousands of nodes, hundreds of terabits per second of traffic, ran the test with a variety of people from the industry. Mode won the competition. But the interesting thing was that on a Macintosh laptop computer, the Mode algorithm was able to calculate an optimal IP network for AT&T's overlay in less than 30 seconds. The second place team, using quite a bit more compute resources, took almost 24 hours. And it has to do with the fundamental difference in the way the algorithm works and the way our, what we call perfect network control, addresses a packet switch network, particularly a large-scale network like a wide area network. So with that, we've taken this math discovery, we've implemented it as a software-defined network that runs, in this case, as we've talked about, on top of the Ericsson Edge Gravity system. And that allows us to deliver this flexible, reliable, and cost-effective core, software-defined core for enterprise, and that's the focus that we have. And the price point for that is a fraction of the cost. Because if you look at our network, it's basically software blade servers connected to layer 2 network. There's no Juniper equipment, Cisco gear, no offense to any of you, we still like that stuff, but we don't use it in our network because we're running all of that, the control and data plane in software. And that's one of the beauties of the architecture and gives us the flexibility that we have. And so I'm actually ending a little bit early, but that's the end of my thing, and we're focused on businesses, enterprise, and working with service providers.